Okay, so today we will be talking about vitamin D. In this lecture, we will be talking about the synthesis and metabolism of vitamin D, and in the upcoming lectures, we will be studying about the regulation of vitamin D and the diseases that occurs due to deficiency or hyper taking of vitamin D, hypervitaminosis of vitamin D. So vitamin D, it is basically a derivative of the cholesterol molecule. You know the basic structure of cholesterol molecule. Here is the structure of cholesterol molecule. It contains four rings. One is a ring, B, C, and D, and it contains a side chain and an OH group at carbon number 3. That is the structure of the cholesterol molecule. We have drawn certain organs of our body that take part in the synthesis of vitamin D. The first organ of our body which we have drawn here is the GIT, that is the gastrointestinal system of our body. Then we have drawn the circulation, then we have drawn the skin, then the kidneys, the proximal convoluted tubules of the nephrons, and finally we have here is our sun, that is the ultimate source of energy. So what happens that first of all, in our skin there is a compound which is called 7-dehydrocholesterol. When the ultraviolet light from the sun falls on our skin, then this compound 7-dehydrocholesterol molecule is converted due to the falling of ultraviolet light on the dermis and epidermis layers, especially dermis and epidermis layers of our skin. This compound will be converted into cholecalciferol. This cholecalciferol compound is the inactive form of vitamin D. Here it is the inactive form of vitamin D. So for activation, this cholecalciferol must be modified. What modification should occur in this compound? The first modification is that it should be hydroxylated at carbon number 25. It means that at carbon number 25 of this compound, hydroxyl group should be added, and the second modification that will take place for the activation of this compound is that at carbon number 1 hydroxyl group should be added. So two hydroxyl groups should be added to this compound. The first hydroxyl group should be added at carbon number 25, and the second hydroxyl group should be added at carbon number 1. So let's come to the first hydroxylation. When this cholecalciferol, here we have denoted in our diagram the cholecalciferol with CCF. So when this CCF reaches through the blood to the liver hepatocytes, here it is our liver, and I have denoted this part of the liver. It is a single cell, that is the hepatocyte. So when this CCF reaches the liver hepatocytes, then in the liver hepatocyte there is an enzyme that adds hydroxyl group at carbon number 25 of this compound, and this enzyme is known as 25 hydroxylase. That's why it is known as 25 hydroxylase, because it adds the hydroxyl group at carbon number 25 of this compound. When the 25 hydroxylase adds a hydroxyl group at carbon number 25 of the cholecalciferol, then this cholecalciferol will be converted into 25 hydroxycholecalciferol. It means that in cholecalciferol, hydroxyl group has been added at carbon number 25. That's why the name is given as 25 hydroxycholecalciferol. Here you should know that the 25 hydroxycholecalciferol is the storage form of vitamin D. All of the vitamin D that is stored in our body is in the form of 25 hydroxycholecalciferol, but still this 25 hydroxycholecalciferol is inactive. Here it is inactive. So for activation of this compound, the second modification or the second hydroxylation should take place at carbon number 1 of this compound, but the second hydroxylation that occurs at carbon number 1 does not take place in the liver hepatocytes. It rather take place in the proximal convoluted tubules of the kidneys. So then from the liver hepatocytes through the blood circulation, this 25 hydroxycholecalciferol will move to the kidneys. In the kidneys, the proximal PCTN, proximal convoluted tubules of the nephrons, there is a specific enzyme which is known as 1-alpha hydroxylase. This enzyme adds another hydroxyl group at carbon number 1 of the 25-hydroxycholecalciferol. That's why the name is given as 1-alpha hydroxylase. It means that it hydroxylases the 25-hydroxycholecalciferol at carbon number 1 by adding another OH group, that is the hydroxyl group. And when this compound adds another hydroxyl group at carbon number 1 to this compound, then the 25-hydroxycholecalciferol will be converted into 1,25-hydroxycholecalciferol. And now this 1-hydroxycholecalciferol is the active form of vitamin D. The active form of vitamin D is also known as calcitriol. Here you should know that we take vitamin D in different forms from different sources. We take vitamin D from plant sources as well as animal sources. The vitamin D that we take from plant sources in our food is called ergocalciferol, and the vitamin D that we consume from animal sources in our diet, that is known as cholecalciferol, the CCF. But once ergocalciferol enters into our GI tract, that is the GIT, or simply the digestive tract of our body, then this ergocalciferol will be converted into CCF, that is the cholecalciferol form. Then this CCF will moves from the intestinal mucosal cells through the blood circulation to the liver hepatocytes, and in the liver hepatocytes again this CCF will be hydroxylated at carbon number 25 by this compound and will be converted into 25-hydroxycholecalciferol, and all of this phenomena will occur again. So in this lecture we have learned about the synthesis of vitamin D, that how vitamin D is synthesized in the skin, and how vitamin D that we consume in our diet is metabolized in the blood circulation and in the hepatocytes of our body, and in the hepatocytes of our liver and the proximal convoluted tubules of the nephron, how vitamin D is activated in these two organs of our body. In the upcoming series we will learn about the regulation of vitamin D and the diseases that are caused due to the hypervitaminosis of vitamin D or deficiency of vitamin D. So up to now it's enough. We will meet you in the next lecture.